Okay, so hello. So today we're going to talk a little bit about cardiomyocytes and autorhythmic cardiac cells and kind of how they work and the differences in between them. As you can see here, they're very similar to the structures that we can see. They have this kind of like, um, looks like a bridge shape to them. And they tend to have a lot of the same channels as well, but they work a little differently. So, cardiomyocytes, they depend on something known as the Bourne or on action potential propagation to come into the cell and start turning it on, while these other rhythmic cells make their own system. They work by themselves and they keep on going. That's why they're autorhythmic. They're able to continue going. So first we'll talk a little bit about the autorhythmic cell. So here we have something called the HCN channel, or the hyperpolarized calcium something channel, and that allows hydrogen to come into the cell and propagate it, or to boost the RMP up, and that helps activate the IF, also known as the funny channel. And I'm not sure exactly, well, I know kind of, but the IF stands for the funny channel, and this over here is calcium L or L and T type gated channels that exist here. So a little bit about L and T type channels. So L type calcium channels are long-lasting channels that are able to continue bringing in calcium momentarily or time after time, while T channels are transient or fast channels that are able to bring calcium in at a blink, very quickly, like a blink of an eye, quickly, in case we need it. So they both have their own uses, and they open up depending on which one's needed. Here we have the SER, or smooth endoplasmic reticulum. Here we have the sarcomere, and we have an RYR channel here, and the circopump. Just like in smooth muscle and stuff, the heart is a type of smooth muscle. It's able to use calcium for both inside the cell, the SER, and outside the cell, the ICF. And then here we have the NCX, or sodium calcium exchange pump, which allows 3 sodium to come in and 1 calcium to go up. And yeah, this is a sarcomere where things happen. As you can see, we also have the NCX here, and then we also have L and T type calcium channels here. We have an SR, and then we have the sarcomere here. But we also have a couple other things in the cardiomyocyte. We have a voltage gated sodium channel known as the INA plus. We have 4 different mechanically gated channels here: the I transient, the I ultra rapid, the I rapid, and the I slow. And these here help control the RMP of the cell to continue to have it go and be able to rest at the same time, so that our ventricles can contract and relax, so that blood can go through and not just stay stagnant in our body. So, as you can see, the bong comes and it hits inside and starts the cell going, allowing voltage gated channel here to open, allowing sodium to come in, and that helps the cell start depolarizing. And once it depolarizes, it needs to go repolarize, and these here help it repolarize in different rates and at different times. And so, as we can see here, I guess something to know is that the cardiomyocytes and the autorhythmic cardiac cells, they start at 90 RMP instead of the normal 60, negative 60 or negative 70. So we'll be starting at negative 90. So for the cardiomyocyte, once you add the INA, it causes the action potential, or the depolarization, to spike up at a rapid pace.
Yeah,
And our-
sodium channel.
yeah, the
Ina.
sodium, the sodium channel, the INA, will cause that to happen. So in order for that to go down and not just completely break, we use the ITO, or the I transient. That's what the toe stands for.
ITO. Yes.
The TO, to quickly open up a leak channel so that we can be able to repolarize the cell, and so we'll be able to do that rapidly. So as we start here, we add the ITO, and then after that, calcium comes in and tries to keep the polarization up, depolarized. But that's why we also have these other ones. The I ultra rapid also comes in and helps it speed it along, and same for the R. And lastly, the IS comes in and actually makes it go into a little bit of a plateau, where voltage gated calcium is able to start being closed and or open, so that calcium can leave and enter, so that we can start going into a rapid repolarization. And this is also caused by something known as IK, or potassium. And that is kind of how the action potential chart for a cardiomyocyte tends to look at under normal state.
Where is the phase 1, 2, 3, 4 of that?
Yeah, so phase 4 is
can
here.
You label it? Yes.
Yeah. Phase 2 is up here, right?
That's 1.
Phase 1, and then this is phase 2 right here.
In the middle, yeah, the phase 2 there.
And then phase 3 is here.
Yeah, and then so rectifying channel, the IK is in 3. That spot is there.
Got it. That makes sense.
It start to open there, but no. So that was should go down to 3 area.
Like this.
Here you are.
That helps. Okay. Yeah. We'll kind of label this a little differently. We'll put a 3 here, and then we'll go like this. Boom.
And then phase, where's
4.
the 0?
0's right here. Yeah. So this rapid spike up is a 0. 1 is the very peak. 2 is the starting repolarization into a plateau. 3 is the end of a plateau going down into rapid repolarization. And then 4 is over here when it's starting to polarize.
Yeah. Can you write the number 4 there too?
Oh yeah, I guess we can write a number 4 here too.
Yes.
Just like steady pace.
Yes.
And it's actually, this chart here is going to look very different from this chart here for the autorhythmic. Because as you can see here, cardiomyocyte is one big action potential, because it helps our ventricles contract here to pump blood, and then here it relaxes so that we're able to let more blood in to the ventricles, so that we can be able to continue opening and closing those and passing blood through. While autorhythmic cells tend to be open or on pretty regularly. So unlike our friend here, for the cardiomyocyte, autorhythmic tends to look kind of like this for their action potential, and only tends to have 3 phases: a 4, a 0, and a 3. Sorry, I didn't write that well. Here we go, 3. So, what are they? Well, here as you can see, we have little spikes up whenever it starts to depolarize up. Those are known as pacemaker potentials, and they allow us to continue pumping and continue going on in a not rapid, but in a steady pace. And when we start doing the action potential here and start depolarizing, we're able to come down pretty naturally without the need of all these channels here. Because we don't really have a resting state. We go down temporarily, but only very temporarily. As you can see, it goes from 3 to 4 very rapidly. So we're open and closed. Even though we have And we start at -90. We're able to do these peaks pretty well,
Okay.
and that's thanks to the HCN that can the hydrogen is able to keep that going.
There are different names of Bonnie channel. Do you know all the names of Bonnie channel?
The bonding channels,
Bonnie channel.
funny channels.
Uh-huh.
I don't know all the names of the funny channels, but I know this one exists here.
Okay. So HCN channel is Bonnie channel.
This is a funny channel.
And IF channel is Bonnie channel. They are all same names.
Okay, these are the funny channels.
Mm-hmm.
Okay, what about the NCX? Is this a funny channel?
No,
No,
it's
no
not.
funny channel there.
Mm-hmm. So why funny channel is funny channel? What do they call funny channel?
The funny channel is called the funny channel because when it was created, the discoverers of the funny channel or the IF channel thought it was kind of funny, and so it just kind of stuck as the name for the channel, and it's continued ever since then.
Okay, funny channel they named it because it opens when the cell become hyperpolarized.
Oh well, yeah, hyperpolarized CN with hyperpolarized cyclic neurons. Instead of the usual opening or when we depolarize, the HCN and the IF open when the cell is hyperpolarized, or this portion here when we're starting to dip under, and they cause the cell to depolarize quickly back up. That way we continue going.
Yes, and number 3 is above the threshold.
It's above the threshold. Right. It's this repolarization right here.
Do you have anything to say?
I don't know if we have anything to add. Here we go. Cardiomyocytes, autorhythmic cardiac cells. Boom. Thank you.